In late-stage development, specifications are absolutely essential. But what about in early discovery? Should you have specifications at all? And if you do, what are they really meant to accomplish? Let's dive in. First, let's be clear on what a specification is. It is a defined set of tests with acceptance criteria used to decide if a material is suitable for use. But in the fast-paced world of discovery, we need to apply that concept very carefully. A common mistake is to confuse what's needed for discovery with what's needed for later development. In discovery, formal regulatory specifications are not expected. At this stage, it's best to think of specs as internal quality thresholds. Their job is to protect the quality of your interpretations and decisions, not to demonstrate compliance. So why have any thresholds at all? Well, without some basic guardrails, things like purity and identity can drift over time. This can seriously contaminate your structure-activity relationship conclusions, or SAR. A minimal set of criteria helps ensure that the decisions you make are based on materials that are actually comparable to one another. A common internal practice is setting a purity threshold for compounds before they enter biological testing. For example, you might decide that 90% purity is perfectly acceptable for those early, high-throughput screens. But for more advanced or confirmatory studies, you might raise that bar to 95%. The right number always depends on the risk associated with the decision you're making. The context here is everything. The right purity cutoff depends on things like your assay sensitivity, the risk of misinterpreting your SAR data, and how likely it is that any impurities might affect the biological activity you're measuring. A single, universal purity number rarely makes sense across an entire discovery program. However, one thing that always matters, even in early discovery, is identity confirmation. At the very minimum, you need evidence that is consistent with the structure you think you made. This usually means checking for the expected mass and retention behavior, and having appropriate supporting data ready when needed, just to be sure you're testing what you think you're testing. What about things like residual solvents or leftover reagents? In discovery, these are usually handled pragmatically. You probably do want to need to run a full panel of compendial tests like you would for a GMP batch, but you should definitely control for obvious risks, especially as your compounds start moving toward in vivo studies, where safety becomes a much bigger concern. So when does impurity monitoring become truly important? It's crucial when you see some unexpected activity, when you suspect a compound might be degrading, or when you're using a compound in more definitive make-or-break studies. At that point, you need to tighten your criteria to protect the integrity of your interpretation. One of the biggest risks is treating your early discovery thresholds as if they were final development specifications. If these early specs are documented too formally or set too tightly from the start, they can become major constraints later on, even when they were never intended to be. This can create a lot of unnecessary headaches down the road. A much healthier approach is to define your internal standards as decision thresholds, not as regulatory commitments. It helps to use language like fit-for-purpose criteria rather than final specifications. This simple shift in wording reinforces their role as internal guidance, not a locked-in rule. So what does a practical, minimal package look like? It might just include support for the compound's identity, a purity estimate that's suitable for the assay stage you're at, and some basic notes on stability or handling. You want to keep it lean and flexible, adjusting it as the program matures. You'll know it as time to tighten those criteria when you start moving toward selecting a clinical candidate, making tox-enabling batches, or preparing for your IND submission. That's the natural transition point where you shift from loose discovery guidance to much stricter development control. Ultimately, the strategic principle here is to protect your decision quality while preserving speed and flexibility. Overly rigid standards set too early can slow down discovery and create unnecessary complications for the development team later. So, to wrap up, specifications in discovery should be lightweight and fit for purpose. They exist to protect your scientific interpretation, not to satisfy future regulatory expectations. The key is to set clear internal thresholds, and then allow them to evolve as your program advances. In our next episode, we'll discuss exactly when and how to tighten those analytical controls as you transition from discovery into formal development. Thanks for watching, and be sure to subscribe for more.